In this video, we'll simplify expressions involving indices. They are also known as bars or exponents. I will be solving only a few questions from each part. You can solve the rest of the questions, and the solutions will be provided at the end of the video. Let's start with question B. It's y squared times y cubed times y to the power 5. Over here, the base, that is y, is the same, and the exponent 2, 3, 5 are different. The operation used is multiplication. Hence, we will use the law a to the power m times a to the power n equals a to the power m plus n. And we have y to the power 2 plus 3 plus 5. And that gives us y to the power 10. Question D, d to the power 2 times d to the power 10 times t. Over here too, the bases are the same. The exponents are different and the operation used is multiplication. We will be using the same law. Here it will be t to the power 1, which gives us t. So our solution is given by t to the power 2 plus 10 plus 1, and that gives us t to the power 30. For this question, the operation used is division. We will be solving these two questions. The law used will be a to the power m divided by a to the power n is given by a to the power m minus n. So we have question B, y to the power 14 divided by y to the power 10, and that is given by 14 minus 10 and y to the power 4. And that is given by b to the power 7 minus 0. We have b to the power 7. Let's do question B. We have 10 to the power 19 divided by 10 to the power 16. We can use this law e to the power m divided by e to the power n is equal to e to the power m minus n. Over here, the base is the same, which is 10. So we can use the law. We have 10 to the power 19 minus 16, which gives us 10 cubed. For question G, we have x to the power 9 times y to the power 8 divided by y to the power 7, x to the power 6. We can rearrange this to give us the following expression. Now we have similar bases, and we can use this law again. So x to the power 9 and x to the power 6 has a similar base, that is x. So that gives us x to the power 9 minus 6 times y to the power 8 and y to the power 7 have the same basis, which is y. And we can do it. We can apply the law, which gives us y to the power 8 minus 7. This gives us x cubed times y. For the next question, we're doing question H. So that's ABC the whole raised to 3, ABC the whole raised to 2. Here ABC is the base, and the exponents are 3 and 2. So we can simply write it as ABC the whole raised to 3 minus 2 by applying that formula. And we have AEC. In this question, we will be using the following law. A to the power minus m is equal to 1 over a to the power m. We will also use a to the power m times a to the power n equals a to the power m plus n. We also have a to the power m divided by a to the power n equals a to the power m minus n. So for our first question, we have x to the power minus 2 times x to the power minus 1. we have to write the following expressions only using positive indices. So over here, the bases are the same, and the operation used is multiplication. So we have x to the power minus 2 plus minus 1, which gives us x to the power minus 3. And using this law, and we have 1 over x to the power 3. For the next question, we have t to the power minus 2 over t to the power minus 3. We can write this or simplify this using the third law or the third formula. Here the bases are the same, which is t, and we have minus 2 minus 3, or t to the power minus 2 plus 3, and that gives us t to the power 1, or t. For question D, we have 2 times a squared times b cubed, 6 times a to the power minus 3 times b to the power minus 5. Now we can take 2 and 6 outside, so we have 12 times. We can write these in the denominator using the first rule over here. So we have a squared times b cubed divided by a cubed times b to the power 5. We can simplify this by using the following formulas. Observe the bases and only apply the formulas to similar bases. So we have a to the power 2 minus 3 times b to the power 3 minus 5. That gives us 12 times a to the power minus 1 times b to the power minus 2. Since we have to write these in positive indices, we have 12 over ab squared. For the next question, we have 27 raised to minus 1, x raised to minus 1, y raised to minus 2. So y raised to minus 2 will go to the numerator. 27 to the power minus 1 will come down. To the power minus 1 will also come down to the denominator. So we have y squared over 27 times x. We'll be using the same formulas as the previous question. So for the first part, we have 3 over 4 to the power minus 2, which can be written as 3 times 4 squared using this formula. And that gives us 3 times 16, which is 48. For question C, we have 3 to the power minus 1 times 9 squared times 27 to the power minus 1. That can be written as 9 squared over 3 times 27. We can expand it, which gives us 1. In question E, we have 0.2 raised to minus 2, which is also equal to 0.2, 1 over 0.2 squared, which is equal to 1 over 0.04. We can also write it as 100 over 4, and that gives us 25. You can solve the rest of the questions, and the solutions will be provided at the end of the video. Here we have to simplify the following expressions. Let's start with question B. We have minus y raised to minus 2 and minus y raised to minus 1. We can expand it and write it as minus 1 times y to the power minus 2 and minus 1 times y to the power minus 1. minus 1 times minus 1 is 1, and y has the same base and the exponents are different. The operation uses multiplication. So we can use the first root. We have y to the power minus 2 plus minus 1, which gives us y to the power minus 3. For question D, we have minus 2 times d to the power minus 1, minus 3 times d to the power minus 2, and minus 4 times d to the power minus 3. Here we can take out all the coefficients. So that's minus 2 times minus 3 times minus 4. And so we're grouping similar terms. Here the bases are the same. So d to the power minus 1 times d to the power minus 2 times d to the power minus 3. This gives us 24 minus 24, because it's uneven number of minus signs, times d to the power minus 1 plus minus 2 plus minus 3. So we have minus 24 times d to the power minus 3 plus minus 3, so that's minus 6. For question F, we have 2 times d to the power minus 1 cubed over 60 squared, which gives us 2 cubed times d to the power minus 1 into 3. So the rule used for this is a to the power m raised to n gives us e to the power m times n over 60 squared. So 2 cubed is 8 over 6 times t to the power minus 3 over t squared. We can use this rule, and we have 4 over 3 times t to the power minus 3 minus 2. So that's 4 over 3 times t to the power minus 5. For this question, we'll be doing 3 of them. Let's start with question B. We have 3 cubed raised to 3. We can use this law or rule. That gives us 3 to the power 3 times 3. It's 3 to the power 9. Next, we just have to bring this to a single index or simplify it to a single index. So we can stop there. Next, for question E, we have y to the power minus 1 over y to the power minus 2 cubed. So that can be written as y to the power minus 1 minus 2 cubed using this formula. And that gives us y to the power minus 1 plus 2 cubed. It's y to the power minus 1, y to the power 1 cubed. So that's y raised to 1 times 3. And that's y cubed. Next we have question H. So that's minus 1 raised to 4 raised to cube. We can use this formula again. So we have minus 1 raised to 4 times 3 minus 1 raised to 12, which is also equal to 1. Let's solve question B. We have 2 squared raised to minus 1. This can be written as 2 to the power 2 times minus 1 using this formula. So we have 2 to the power minus 2. We can also write that as 1 over 2 squared or 1 over 4. Next we have question D. 6 to the power minus 2 raised to minus 1, which is similar to that. So we can write that as 6 to the power minus 2 times minus 1, which gives us 6 squared, and that's 36. Next, let's solve question F. We have minus 2 to the power minus 1, which can be written as 1 over minus 2 using this formula. or we can also write it as minus 1 over 2. Let's start by solving question C. We have 4 to the power minus 2, a to the power minus 3, b to the power minus 1 squared, which can be written as 4 to the power minus 2 times 2, a to the power minus 3 times 2, over b to the power minus 1 times 2. So we have 4 to the power minus 4 times e to the power minus 6 over b to the power minus 2. Next we have question E. We can write this as 3 squared times x squared times y to the power 2 times 2 and z to the power 3 times 2 using this formula, which gives us 9 times x squared times y to the power 4 times z to the power 6. Next we have h 2z squared over 3t cubed, which can be written as 2 cubed times z to the power 2 times 3 over 3 cubed times 3 to the power 3, which can be written as 8 times z to the power 6 over 27 times t cubed. Next we have question J. Minus 2 times x squared raised to minus 2, and that is minus 2 raised to minus 2 times x squared times minus 2. This can be written as 1 over minus 2 squared times x to the power minus 4, which can also be written as 1 over 4 times x to the power 4. Question B. 5 to the power 1 over 3 raised to 6. We can write that as 5 raised to 1 over 3 times 6 using this formula, which gives us 5 squared. Next we have question D. X squared raised to 1 over 3. We can write that as x to the power 2 times 1 over 3, or x to the power 2 over 3. Next we have question G. AB squared raised to 1 over 2. We can write that as a to the power 1 over 2 times b to the power 2 times 1 over 2, and that can be simplified as over a to the power 1 over 2 times b. Let's start with question A. 4 cubed minus 1 over 2. We can write that as 4 raised to 3 times minus 1 over 2, or 4 to the power minus 3 over 2. Question D. We have 19 raised to 3 over 2 raised to 1 over 3. We can write that as 19 raised to 3 over 2 times 1 over 3, which can be simplified as 19 raised to 1 over 2. Next we have question F. K to the power minus 1.5 over root k minus 2. Here we have the formula we can write this as k raised to minus 3 over 2 over k to the power half, as this is the square root, raised to minus 2. We can simplify this. We have k to the power minus 3 over 2 minus 1 over 2 raised to minus 2. We're using this formula. So we have k to the power minus 4 over 2 raised to minus 2. That gives us k to the power minus 2 raised to minus 2, which can be written as k to the power minus 2 times minus 2, and that's k to the power 4, which is our final answer. We have to write the following expressions without using brackets. Let's do question A. We can expand this by multiplying the index into each base. So that gives us 5 over 5 raised to 1 over 6 times b raised to 1 over 6. For question C, we have 3 times square root of x cubed. We can write square root of x as x to the power 1 over 2 cubed using this formula. That gives us 3 times x to the power 3 over 2. Question D, we have square root of 3x cubed. This again can be written as 3 to the power 1 over 2 times x to the power 1 over 2, the whole cube, which can be written as 3 raised to 3 over 2 times x raised to 3 over 2. Here, let's do question E. We have square root of 25 times y squared, which can be written as 25 raised to 1 over 2 times y squared raised to 1 over 2. We can write 25 as 5 squared raised to 1 over 2 times y squared 1 over 2. Now using this formula, we have 5 squared times 1 over 2 times y squared times 1 over 2. That gives us 5 times y. And let's do question H. We have x to the power 1 over 4 times x to the power 1 over 2 raised to 4, which gives us 1 over 4 times 4 times x to the power 1 over 2 times 4. That gives us x to the power 1 times x to the power 2. We can simplify this further using this equation, which gives us x to the power 1 plus 2, and that's x cubed. Now for question J, we have square root of a to the power minus 4 over a to the power minus 1, which gives us a to the power minus 4 over a to the power minus 1, the whole raised to 1 over 2 using this formula. We can also write that as e to the power minus 4 minus minus 1, or we have minus 4 plus 1, that's minus 3. So that's e to the power minus 3 over 2. And that's your final answer.